was backed out of the processing facility in early July, just after the 4th of July holiday. The boosters and external tank were stacked in parallel in the vehicle assembly building while the work was going on in the orbiter processing facility. The countdown demonstration test with the flight crew was conducted just a few weeks ago, and the flight crew was certified in emergency escape procedures. This is the orbiter access arm as it was attached to the vehicle once Discovery rolled to the pad last month, and the rotating service structure was then moved into position around the orbiter to allow the installation of the payloads and also access to various parts of the vehicle for the Kennedy launch team. Payloads were installed into the payload bay out of the launch pad in the vertical position. And the payload bay doors were closed for flight early Tuesday morning during our countdown. Countdown began on time at the T-minus 43-hour mark at about 3 p.m. on Monday. Count has been going very smoothly, which leads us up to this morning. It's traditional for the crew to arrive several days before the launch. They go through flight data file reviews, and the commander and pilot practice approaches and landings to the shuttle landing facility to hone their skills. They practice in the shuttle training aircraft. Crew also has medical exams while here at KSC prior to launch, and they perform fit checks of their flight crew equipment.
Hello and welcome to Future Watch. I'm Donna Kelly. As more and more pictures pour in from the surface of Mars, anticipation of a manned mission to the Red Planet is rising. On Tuesday, the National Research Council issued a report evaluating NASA's efforts to develop a life support system capable of keeping astronauts alive during a months-long journey to Mars. Among the conclusions, replenishing the food, water, and oxygen needed for the 2-year round trip would be economically unfeasible and perhaps even impossible using today's technology. The report also criticized NASA's life support research as lacking clear objectives. Last summer, we visited the Johnson Space Center for a first-hand look at NASA's efforts to find ways to keep humans alive on extremely long space flights. As Lori Waffenschmidt reported, the outlook a year ago was far rosier than the fairly bleak picture painted by the Research Council's findings.
Imagine being shut away in a chamber like this for up to a year, living in your own little world. Scientist Nigel Packham hopes it happens to him sometime in the next decade. Last year, Packham, a Lockheed Martin researcher, spent more than 2 weeks cooped up in a chamber the size of a jail cell at NASA's Johnson Space Center. He was all alone with only a bunch of plants for company.
I spent 15 days in a 100-square-foot area to demonstrate that plants can keep me alive by producing my oxygen for me and taking up my carbon dioxide.
NASA scientist Don Henninger says the Advanced Life Support Program, as it's called, is a crucial part of preparing for long trips into space.
We'll have to recycle the water and the air, and even in the cases of long-duration missions to the Moon and Mars, we'll actually have to grow food and recover resources from the solid waste.
Nigel Packham says the plants proved to be responsive roommates during his 15-day mission to nowhere.
When I exercised, they in fact responded within about 10 minutes to provide more oxygen and take up more carbon dioxide. Quite remarkable.
And Packham says there were psychological benefits too.
It also makes you feel a little bit like you're outside. It smells very different. It's like a breath of fresh air.
NASA is gearing up for another 15-day test, this time with a crew of 4 in a larger chamber. Anything that can be recycled will be, everything from air to shower water to urine.
The second level of the chamber is where we have all of our air revitalization hardware. So these systems remove carbon dioxide from the atmosphere that's exhaled by the test subjects. We take the carbon dioxide and split out the oxygen molecule from the carbon dioxide for reuse in breathing.
This bioreactor, as I say, takes all the wastewater and removes all the organic material as it goes up. What you're seeing here are actually microbes or bacteria. May look pretty nasty, but in fact, they're doing a wonderful job microbiologically. This is the water we actually end up with. This is the clean water, which is much, much cleaner than you'll ever drink at home.
A year from now, NASA plans an even longer test, one that'll require 4 people to live in a larger multi-level chamber like this model for up to 3 months.
It's almost equivalent to putting 4 people in a house and leaving them in there for 15 days or 30 days or 60 days. So I think the psychological aspects of how those folks interact is going to be one of the more interesting results of that test.
And when it comes time for the ultimate test, an experiment that'll last a whole year, Nigel Packham says he hopes he's one of those chosen.
Well, actually, it really wasn't as bad as it looks. Once you get over the initial shock when the door is closed, and as long as you're not claustrophobic, I have a window that I can look out on the outside wall, and there's always someone out there. So, no, I didn't feel lonely at all.
Packham says this research, though complex, is critical as America prepares for future space missions.
If I really didn't think that we were going to go back to the moon or to Mars, I wouldn't be at my job every day. And I think that's the only way we're going to get there is by actually showing that we can keep people alive for periods of up to a year in chambers like that.
Lori Waffenschmidt, CNN, reporting.
In February of this year, a crew of 4 was sealed away in a chamber for a 60-day test of life support technologies. A NASA spokesperson deemed the experiment a success, and on September 19th, another crew of 4 will participate in a 90-day test, and we'll let you know how that turns out.
Astronomer and geologist Eugene Shoemaker has died. He was killed in a car accident while he was working in Australia. Shoemaker made a name for himself in this world because of something that he discovered from another. CNN's Joey Chen explains why he will be remembered.
Because he gave it to a comet. Not just any comet, but one of the most interesting ones in recent years. In March of 1993, Eugene Shoemaker, his wife Carolyn, and a colleague, David Levy, discovered a fragmented comet. They named it Shoemaker-Levy 9. It was a remarkable discovery because the comet was heading straight for the planet Jupiter, giving scientists their first opportunity to watch a comet as it hit a planet. What also made this event interesting was the comet itself. It was expected to fragment as it came closer to Jupiter, which is exactly what it did, breaking into 20 distinct pieces. A newly repaired Hubble Space Telescope was brought into play, and it captured these spectacular images. As fragments from Shoemaker-Levy 9 hit the planet, huge explosions were recorded, throwing fireballs, heat, and dust hundreds of miles up into the atmosphere. One fragment was described as the size of a mountain, and the crater it left behind was visible from even Earth-bound telescopes. Shoemaker and his wife were in Australia to search for asteroid impact craters when the accident occurred. He was 69 years old. Joey Chen, CNN, reporting.
For years, scientists have tried to understand why there were major changes in the Earth's climate when life was forming here. Now, some geologists say they may have discovered what happened. CNN's Jennifer Arthur has the story.
Scientists at the California Institute of Technology have concluded that 500 million years ago, the Earth shifted 90 degrees, like a basketball spins on its way to a game-winning hoop. That 90-degree tilt is the biggest tilt ever theorized for the planet Earth.
By the end of this 15 million year sequence, what used to be the poles are now at the equator. Australia has rotated 90 degrees, and North America has gone from the southern hemisphere up to the equator.
Joe Kirschvink, a paleomagnetic expert, says the Earth's tilt moved cold continents into the tropics and previously tropical lands to the north and south poles. For years, researchers have theorized that the Cambrian explosion, or Big Bang, caused new life forms to emerge, many multi-celled organisms with descendants, including human beings.
In total, something like 40 different major groups of animals make their first appearance during this time. It's an incredible bloom.
This latest theory explains why such a major upheaval in the Earth's climate occurred.
This global reorganization from one supercontinent to another one may have been a fundamental rearrangement of planetary mass.
They call the unique geological phenomenon the true polar wander. Their explanation puts the continental shift at a rate 10 times faster than the tectonic plate shift now underway. This new theory is not universally accepted by all geologists. Joseph Meertz, a paleomagnetics expert at Indiana State University, says supercontinents moved relatively quickly due to churning rocks beneath the surface. Chris Scortese of the University of Texas in Arlington says evidence used to reach this new theory is scanty. However, while scientists at Caltech concede their new theory is radical, they say it can be tested. Jennifer Author, CNN, Pasadena, California.
It's what we all expect of ourselves in the dark escape of the movies, a willing suspension of disbelief. For example, a tough Hollywood star plays president, say Harrison Ford in Air Force One. So what do we do with this?
Its implications are as far-reaching and awe-inspiring as can be imagined.
The president plays the president in Contact.
Our president actually got to sit down and talk about the possibility of there being life outside of our planet. It happened. I mean, Clinton did it.
True, he did. Last summer when a bacteria-stained rock from Mars was discovered. So director Bob Zemeckis took this and made this. The White House sent Zemeckis a letter calling the use of the president's image fundamentally unfair. You have manipulated images of the president's public statements, taken them out of context. The question some filmmakers have asked is, so what? It's a First Amendment right, and after all, politicians, especially the president, are public domain. Woody Allen used filmmaking trickery to share scenes with public figures in Zelig. Oliver Stone visually altered historic moments for JFK. And with Zemeckis' help, JFK hammed up this scene with Tom Hanks.
I believe he said he had to go pee.
We spoke to Zemeckis before the flap.
But they're already giant media stars, and their images, I mean, I don't think a day goes by when you don't see a television image of the president.
But observers say even the president should have some control over his image.
It blurs further the already almost invisible line between reality and entertainment. You know, the president is just another prop, just another figure for your fun and games movie.
The fact is, the general public is becoming so much more accustomed to the blurring of the lines between politics and entertainment. These days, one can not only find politicians inside the Beltway, but all over Hollywood.
In the past year alone, viewers have watched Senator Ted Kennedy in Chicago Hope, former Senator Bob Dole on Suddenly Susan. The president even made a cameo on the CBS movie A Child's Wish. Perhaps this trend's made it easier for filmmakers to take greater creative license. But what observers desire and fear is technology that will render digital replicas indistinguishable from the real thing.
Where you can have them say anything you want them to say, that's where the real danger is.
Only if it's not in the right hands. Michael Oku, CNN Entertainment News, New York.
That science has ever...
And that's all for this American edition. I'm Relita Vasilova. Stay tuned now for World Business Today.
Some aspiring young astronauts are already heading to Mars with a little help from their imaginations and a lot of help from mom and dad. Greg Lamont reports on a mission not so impossible.
These young men are about to boldly go where no man has gone before.
Water, Mommy. Yeah.
Okay. Now you ready for your mission?
They are willing to risk life and limb to travel to Mars.
Very comfortable in here.
A final check of all systems. Power, pressure, weather. Mission to Mars is a go.
3, 2, 1, lift off!
The manned round-trip mission will take 3 years, or in this case, maybe a little longer.
You guys, we need these on. You guys, you're messing it up.
And after months in space,
you're firing your edited control rockets.
There is mankind's giant leap.
X-ray mission team, you're very proud. You should be very proud. You've just planted your flag on the surface of Mars.
Maneuvering on the planet can be a bit tricky, but the mission to retrieve soil samples is successful. There's a forecast of high Martian winds, however, and the mission is cut short. The brave souls must return to Mother Earth.
And you are go for hatch opening.
And what did these brave pioneers like most about their trip to Mars?
Getting out on the planet.
And what about you? What did you
I
like?
like collecting the rocks and getting out on the planet.
Wow, and what did you like on the space?
Everything!
All right!
Not too shabby for a group of Cub Scouts. And what an excellent job their parents did pulling it off. A group of parents decided to make Mars the theme of a 4-day scouting camp.
Knew that there were plans for another mission to Mars coming up, and I thought, it just clicked one night, okay, Destination Mars, a space camp for kids.
Using the talents and connections of the parents, the space camp was built on a shoestring budget, lots of donations, and volunteerism. It includes a mock spaceship, space suits and helmets, communication devices, a mission control, and even a little bit of Mars. Scientists say it'll be around the year 2016 before there's a real human mission to Mars. And if you stop and think about that, some of these youngsters really could be the first to step foot on the red planet. Greg Lamont, CNN, Los Angeles National Forest.
And NASA scientists are getting a new look at the sun, complements of a space telescope called SOHO, short for the Solar and Heliospheric Observatory. NASA released new movies this week showing bubbles of gas exploding from the sun's surface, fueled by electromagnetic forces generated deep within the sun. The SOHO spacecraft has been orbiting the sun since December 1995. It gives a clear, unobstructed view of the sun. The research could help scientists understand the solar storms that can disrupt satellites and power transmissions here on Earth.
It was August 7th, 1997. The vehicle was all ready to go out on the pad. It's a busy morning, launch morning, so we were all had a little bite to eat, got into the suit room, got all suited up. It takes quite a while to do that if you've seen a previous flight. But everyone was in great spirits. Everyone was excited to go. Got beam away from the breakfast table. And Steve's all excited. And last but not least, Bjarne got his suit all checked out, and he was ready to go also. The vehicle was out in the pad. It was fully loaded with propellant and fuel, and it was a flawless countdown. It was all ready to go. We departed the operational checkout building, the crew quarters where we stay, for our trip, hopefully our only trip out to the pad for this flight, and due to the great weather and the countdown, it happened our first try. Once in the white room, we get a little bit more equipment on, our harnesses for our parachutes and oxygen bottles, and now we're going to show you inside the cockpit, climbing, kind of doing a chin-up here to get into the seats. A little bit different view than you normally see. Joe Tanner was our astronaut support person to strap us in, try to get comfortable, and on the mid-deck, while that was happening, Steve was getting in the MS3 seat. Kent's getting his helmet on. Jan's doing what she always does. Actually, Jan, if you see on the left down there, is in the cockpit already, and the last but not least was Beamer, or Bob Kerbeam, to get in the MS2 seat, our flight engineer for Ascent. The mid-deck's ready to go with Steve and Bjarne all strapped in. With everyone aboard, it's time to remove the white room. It rotated back, as you can see. At 2 minutes, they give us a call to close our visors, so we put our visors down and turn our suit on.
The following is CNN's coverage of a live event.
I'm Michael Holmes at the CNN Centre, interrupting regular programming to bring you this live event, the coverage of the launch of the Space Shuttle Discovery from the Kennedy Space Center in Florida. Ahead, an 11-day mission for the Discovery. What the mission commander told CNN last week was the most complicated space mission ever. These pictures coming to you live from the Kennedy Space Center. During their mission, the astronauts will study the ozone layer. They'll point a telescope at the comet Hale-Bopp. They'll also test a Japanese robot arm, which is intended for use on the planned International Space Station. The launch now just a minute or two away. The telescope, by the way, is called Krista. It will look not at the stars, but at Earth, examining the ozone layer and the vegetative cover over our planet's jungles and wooded areas.
At T-minus 31 seconds, Discovery's onboard computers will have control of all vehicle functions.
As you can see there on the screen, 1 minute to lift off at the Kennedy Space Center.
T-minus 1 minute. All systems are go for launch of Discovery.
Very busy.
T-minus 50 seconds.
Trip ahead for these astronauts, as the shuttle program manager Tommy Holloway told CNN, we have something for everyone. Let's listen in to the countdown.
T-minus 40 seconds.
Let's go for auto sequence start. 25.
Water will be dumped onto the launch platform in a few seconds to help suppress the sound and shock of the thrust produced by the shuttle at launch. T-minus 15 seconds. 13, 12, 11, 10, 9, 8. We have a go for main engine start. 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery on a mission to study planet Earth.
Roll program, Houston. Roger, roll, Discovery.
Houston is now controlling. The roll maneuver is complete, and Discovery is now in a heads-down, wings-level position, headed to a 160 nautical mile orbit.
Dilemma manifold. Copy, no action on the dilemma.
As always, magnificent pictures of the liftoff of the space shuttle.
34 seconds into Discovery's 8.5-minute climb to orbit this morning. All three main engines now throttling down to 67% of rated thrust as the orbiter passes through the area of maximum aerodynamic pressure on the vehicle in the lower regions of the Earth's atmosphere. Telemetry indicates all three auxiliary power units and fuel cells continuing to perform well. Discovery now downrange from the Kennedy Space Center, 3.5 miles at an altitude of about 7 miles.
Discovery, go at throttle up. Copy, go at throttle up.
1 minute, 22 seconds into the flight, Discovery's three liquid-fueled engines are now back at full throttle, 104% of rated thrust. Discovery now traveling at a speed of 1,900 miles per hour at an altitude of 16 miles downrange from the Kennedy Space Center, 13 miles. The next event will be the burnout and separation of Discovery's twin solid rocket boosters. Again, telemetry currently indicating all three main engines, auxiliary power units, and fuel cells continuing to perform well. Discovery now at a speed of 2,800 miles per hour, downrange from the Kennedy Space Center, 27 miles.
You can see those fuel rockets breaking away from the shuttle there. Another spectacular launch of a space shuttle. This time, the shuttle Discovery from the Kennedy Space Center in Florida. This has been a CNN Live event. We'll return you now to regular programming.
This has been a CNN Live event.
6.5 seconds, there goes the main engines, which is always really a beautiful feeling inside the vehicle. You can see the tank kind of does a little twang. And at T0, we're on our way. And now we're going to show you what that looked like from inside the cockpit, the same exact sequence. There's the engine start, a lot of rumbling, a lot of vibration. You'll see the big jolt here for liftoff. Boom, there goes liftoff, and we're on our way. And if you watch the lighting condition, as we cleared the tower, we did a big roll maneuver to align ourselves for our ascent, and you can see the lighting conditions change, and the sun winds up right in Jan's face for pretty much the whole ascent. Well, as you know, it doesn't take long to get out of Dodge here when those engines get going and start pushing and all that thrust gets going. So we were feeling acceleration about this time. We're a high inclination flight going up the eastern seaboard, 57-degree inclination, going up to about 160 nautical miles. The launch was in kind of a hazy conditions, but we could see SRB set. So 2 minutes after launch, we got rid of the SRBs. And now we're going to show you what that looks like inside the cockpit, the big flash, so you'll have an idea of what we see at SRB set. So it definitely gets your attention. You know the boosters are now separated. We can put our visors up at that time and ride the 3 shuttle main engines to the orbital speed and orbital altitude for the rest of the ascent. After we get off the tank re-enters the atmosphere. That gives you some idea of our speed. This is real time. This is not sped up.
4, 3, 2, 1. Booster ignition and liftoff of Discovery on a mission to study planet Earth.
Just a few hours earlier, the U.S. Space Shuttle Discovery blasted off for an 11-day mission. The 6 astronauts on board have a schedule packed with projects. Topping the list is a study of the Earth's ozone layer, which scientists say will help them better understand ozone depletion. They'll also test a robotic arm designed to perform chores on NASA's future International Space Station.
Um 16:41 Uhr mitteleuropäischer Zeit startete im amerikanischen Cape Canaveral die amerikanische Raumfähre zu einem 11-tägigen Trip. An Bord 6 Astronauten und jede Menge wissenschaftliche Geräte, darunter ein in Deutschland gebauter Satellit. Dieser macht sich in Kürze selbstständig, misst dann alles, was er zu fassen kriegt und wird dann wieder von Discovery eingefangen. So jedenfalls steht's im Drehbuch und das hier war der Start.
5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery.
Pünktlich um 16:41 Uhr unserer Zeit hob Discovery vom Weltraumbahnhof Cape Canaveral ab. Rund 11 Tage lang soll die Raumfähre im All bleiben. Auf dem Arbeitsplan der 6 Astronauten, neben verschiedenen Experimenten, der Einsatz des deutschen Forschungssatelliten Astrospace. Außerdem wird ein in Japan gebauter Roboterarm auf seine Tauglichkeit in der geplanten internationalen Raumstation überprüft. Die Besatzung soll den Satelliten im All aussetzen, nach 9 Tagen wieder einfangen und mit den gespeicherten Messdaten zur Erde zurückbringen. Bestückt mit dem Infrarotteleskop CRISTA soll Astrospace die Erdatmosphäre unter die Lupe nehmen. Aufgabe des Satelliten ist es, Wirbel, Wellen und Turbulenzen in etwa 150 Kilometern Höhe zu untersuchen. Die Wissenschaftler versprechen sich davon neue Erkenntnisse über das Ozonloch.
Space Shuttle Discovery is now in orbit 160 miles above the Earth. The liftoff was spectacular.
3, 2, 1. Booster ignition and liftoff of Discovery on a mission to study planet Earth.
The crew of 6 astronauts is certainly excited about this mission. As it got suited up for launch and the crew members made their way to the launch pad, they had to temper their excitement with the fact this is one of the most jam-packed missions in Space Shuttle history. For the next 11 days, the astronauts will launch a satellite called STS-85, which will look at the Earth's atmosphere and do a check of the planet's protective ozone layer. In addition, the crew members will test some space station hardware, including a Japanese-built hand for the robot arm, which will be able to open doors and pull equipment from the outside of the new International Station once it gets to orbit next year. Mission managers on the ground are happy the shuttle is in orbit, and some of them are now turning their attention to the Mir space station. Right now in space, the shuttle crew is about to launch a satellite from the cargo bay into its own orbit, about 100 kilometers away from Discovery. That launch is supposed to take place over the next 90 minutes or so. This STS-85 satellite, Vanilla, was built by Germany with equipment from several other countries. It'll spend a week looking at us down here on Earth with an eye towards solving the problem of ozone depletion on our planet.
It didn't occur without a slight hitch, but glitches are not new on Mir. 2 fresh cosmonauts joined the crew of 3 aboard the troubled Russian space station after a docking procedure that almost went according to plan. Meanwhile, aboard the United States Space Shuttle Discovery, there is also a slight problem. CNN's John Holloman joins us now from Atlanta for the latest on board the Russian and the U.S. spacecrafts. John?
Hi, Judy. Right now, we were expecting to show you pictures of the Space Shuttle Discovery launching a satellite into space, but there's been a short delay.
a communications problem between the shuttle and its main payload, which you see the gray-looking thing just to the left of the CNN sign on your screen, a German-built science pallet called Christa Spaz. Basically, the crew was trying to talk to the satellite before sending it off into space, but the satellite wasn't listening. After a series of tests, the astronauts decided Christa Spaz had finally picked up the phone. So now the release is set for about 6:30 Eastern Time, about 28 minutes from now. We hope to bring it to you live. And while the crew aboard Discovery was solving that problem, aboard the space station Mir, it was time for a small celebration. The shuttle is flying about 160 miles above the Earth, while Russia's Mir space station is about 80 miles further from the planet's surface. A Soyuz cruise ship was supposed to automatically dock with Mir, but at the last second, the space station's automatic docking system failed, and the docking had to be conducted manually. The two cosmonauts on Soyuz manually pulled their spaceship back a few meters, then forward again, hooking up with the Russian space station's docking port. Mir's first U.S. resident, Norm Thagard, says the manual docking was a first for Soyuz.
To my knowledge, it's always been done automatically. It certainly was automatic on our flight. But again, the crews always train as a backup to do it manually, and they're ready to take over at any moment during that process.
After an hour of checks, the hatch between the two ships was opened, and the long-suffering crew of Mir, including astronaut Mike Foale, were able to hug the newly arrived cosmonauts. In the midst of this, Russian ground controllers joked with the Mir crew about the grainy pictures. The cosmonaut commander responded that he made a special color mixture just for this ceremony. The 5 Mir dwellers will be together until sometime next week when the outgoing Mir crew departs for Earth. So, Judy, as you say, a couple of glitches, one on Mir, one on the shuttle. Shuttle one seems a little bit more minor at this point, but that satellite is still stuck in the cargo bay. It hadn't been released by the robot arm on the Discovery Space Shuttle, and we'll keep watching that and the Mir problems very closely.
This is a very busy flight with over 40 different payloads, some of which you see here in the payload bay. In the middle of the payload bay is the Christa Spaz, one of our primary payloads, which was a scientific satellite looking at chemicals in the ozone layer. And on the very first day, we had to deploy Christa Spaz to give it as much time as we could on orbit. And here Steve and I are in the aft flight deck getting ready for those robotic operations with the shuttle remote manipulator system, the Canadian robot arm on the shuttle. And here I am maneuvering the Canadian RMS to the Christa Spaz grapple fixture so that we can grapple the Christa Spaz, as you see here, and lift it up out of the payload bay and take it over the payload bay and get it ready for deploy. And here it is just before we release it. We're activating all of the experiments and instrumentation on the Christa Spaz satellite, which was controlled by the Germans from Kennedy Space Center, Payload Operations Center. Here's a release of the RMS from the grapple fixture that's on the Christa Spaz, and we send it on its way to a 9-day scientific mission, and we retrieve the Christa Spaz on the 10th day of the mission. To separate away from the Christa Spaz, we maneuvered, actually Rommel maneuvered the orbiter with some separation burns to get us away from the Christa Spaz, and you can see the Christa Spaz as it is separated from the orbiter by moving the orbiter away from it. They were able to get a lot of data in those 9 days. As you can see here, it is now fully separated from the orbiter.
Die amerikanische Raumfähre Discovery hat kurz nach ihrem Start den deutschen Forschungssatelliten Christa im All ausgesetzt. Der Teleskoparm hiefte den Satelliten 280 Kilometer über der Südspitze Alaskas aus dem Laderaum der Fähre hinaus. Er soll neue Informationen über den Abbau der Ozonschicht liefern. Dazu wird Christa Wirbel, Wellen und Turbulenzen in der Atmosphäre untersuchen. Die Discovery soll den Satelliten am Ende der Mission in 9 Tagen wieder in die Raumfähre zurückholen.
Die 6-köpfige Crew wird außerdem einen in Japan gebauten Roboterarm testen. Er soll später in der geplanten internationalen Raumstation eingesetzt werden.
Well, astronauts aboard the U.S. Space Shuttle Discovery are resting now after a busy and productive day. The crew deployed a scientific satellite into orbit about 8 hours after Discovery blasted off Thursday from Florida's Kennedy Space Center.
The release of the satellite, which is designed to observe the Earth's ozone layer, was delayed half an hour because of a communications glitch. During the 11-day mission, the crew is also scheduled to test a new robotic arm developed for the planned International Space Station.
It has been a busy day for space programs. There was a perfect launch for Western Europe's 98th Ariane rocket. Liftoff occurred early this morning in French Guiana. The rocket's main mission is to place a communication satellite into orbit. The U.S. Space Shuttle Discovery astronauts are testing a new robot arm. Only 8 hours after liftoff Thursday, the shuttle crew achieved their main goal of releasing a 4-ton satellite to study the Earth's ozone layer. And Russia's fledgling space program is getting a boost from President Boris Yeltsin. Mr. Yeltsin directed the government to borrow nearly $100 million from banks outside Russia for the country's national space agency.
Die Astronauten der US-Raumfähre Discovery haben den deutschen Forschungssatelliten Christa im All ausgesetzt. Er soll die Ozonschicht untersuchen. Zudem testete die Discovery-Mannschaft einen japanischen Roboterarm, der in der künftigen internationalen Raumstation Alpha eingesetzt werden soll. Am 18. August kehrt die Raumfähre zur Erde zurück.
The Shuttle Discovery lifted off precisely on schedule for an 11-day mission to planet Earth.
3, 2, 1. Booster ignition and liftoff of Discovery on a mission to study planet Earth.
The shuttle's main job, launching the Christa Observatory for more than a week of looking not at the stars, but at Earth. The satellite has telescopes on board which will examine the Earth's ozone layer and also check on Earth vegetation, which might affect the planet's ability to protect itself from harmful radiation from the sun. The shuttle is flying about 160 miles above the Earth, while Russia's Mir space station is about 80 miles further from the planet's surface. A Soyuz cruise ship was supposed to automatically dock with Mir, but at the last second, the space station's automatic docking system failed, and the docking had to be conducted manually. The two cosmonauts on Soyuz manually pulled their spaceship back a few meters, then forward again, hooking up with the Russian space station's docking port. The 5 Mir dwellers will be together until sometime next week when the outgoing Mir crew departs for Earth. John Holloman, CNN Atlanta.
Although Christa was our main payload, our payload bay was very full. As you can see here, forward in the orbiter is to your left, and the first payload you see there is the Japanese robotic arm, or the MFD, the manipulator flight demonstration. Then the next bridge you see there is the technology and applications and science experiment, which had a bunch of engineering models to be tested in zero-G and also scientific experiments. And in the aft, and we'll get a close-up of that soon, you'll see another hitchhiker bridge, and that was the International Extreme UV Hitchhiker. And it had a multitude of payloads looking in the ultraviolet at stars, the Earth's atmosphere, any interaction of the shuttle with the upper atmosphere. A lot of these facilities had optical systems, and so we had a lot of hitchhiker doors, as these are called, which closed to protect them from debris during some of the more sensitive times of flight. We also had some mid-deck experiments, and this is me taking a media sample out of the bioreactor demonstration system. What I was doing, I was growing colon cancer cells to much larger aggregates than we could do in 1G environment, both for colon cancer research and cell research. And there you see the aggregates, and they grew to about 3 or 4 times larger than you would see in 1G.
Just continue now with some of the mid-deck experiments. This is Kent Rominger, or Rommel as we call him, getting ready to do the solid surface combustion experiment. And this is an experiment that is flown on a number of shuttle missions and builds up the knowledge of how materials burn in the zero-G environment of space. In this case, we're burning a plexiglass, a type of plexiglass, and there you see the ignition of that plexiglass. And we filmed the burn for about 10 minutes before the flame, this little blue flame finally extinguished. This is the Swiss telescope used to have a look at the Hale-Bopp comet through the side hatch window, and it views the comet in the ultraviolet, which gives us a better signature of some of the ions and elements coming off the comet that give off light in the UV. Steve spent a fair bit of his time during the mission doing this experiment, and that little bright spot there just to the left of center is the actual comet. You can't see it very well because it's a long distance from the Earth, but by summing up a lot of these images, the scientists can pull out some of the structure in the comet itself. This is Jan and myself just preparing the microgravity vibration isolation mount for one of the experiments we're doing on it. This system isolates experiments, fluid dynamics and material science experiments from the vibrations of the shuttle. And we'll see in the next shot that not only can we isolate, but we can actually shake an experiment with very well-controlled acceleration profiles to look at the sensitivity of experiments, typical of the kind that we're going to be doing at a space station, to the vibrations. And here's a little student experiment we used MIM to do where we can visualize the motion of rather large-looking molecules that would behave the same as molecules in the air around us here today.
Another robot arm on the space shuttle on this flight is the Japanese manipulator flight demonstration. It's a small robotic arm, about 5 feet long. As you see here in the payload bay, we're taking, Steve and I were the operators of this. We're taking it from the stowed position to the operational position where we can maneuver it around. This is the real-time speed of it. It's a very precise instrument, so it's therefore very slow, but it's very functional. We can use it on the space station to take experiments off of a pallet, put them inside of a scientific airlock, or to do very fine tasks that we'll need to do on the space station. One of the things that we did on our flight to demonstrate this capability was we took this arm, which has a grapple fixture at the end of it, attached it to the box you see there. We called it orbital replacement unit. We attach it to the box and unscrew some of the bolts that are attaching that box to its plate. And we actually moving this around to test the performance of the arm and test its capability with a load on the end of the arm. So we moved this orbital replacement unit around, and that's a similar type of activity we'll be doing with this arm, which is on the end of a very long arm on the space station. So we just tested the small, fine arm portion of what will fly on the space station. Another thing we did with this arm was we attached the arm to this door and actually unlocked the door, and we used the arm to open up the door. We did this with a program mode. We also did a lot of operations with some control from the ground, not just with the crew on the flight deck operating the arm. So this demonstrated a lot of capability for the future, and it performed very well. This is sped up a little bit, this function in the last scene you saw. We celebrated the success of this arm by eating some Japanese curry rice. You notice the chopsticks and rice and curry, which was just delicious. We also had a little free time later in the flight when we got an extra day, and one of the things our folks did was some fluid experiments. Fluids tend to form a ball because of the surface tension. They form a sphere, and here we're trying to join the red sphere and the water together, and we were successful after a few tries. Another typical mid-deck activity is exercise. When you're in space, your cardiovascular system doesn't have to work as hard, so we have to exercise to make sure it works fine.
We stayed busy on the flight deck as well throughout the flight. Along with a lot of the payloads came pointing constraints, pointing at various planets, stars, the sun, and back at the Earth. So Kurt and I both stayed busy putting in digital autopilot inputs to point at the different payloads at that. Also on the flight deck, you're usually busy with Earth ops, and just to give you an idea, we bring back more than 3,000 photos of the Earth. And here's some of the Earth going by at over 17,000 miles an hour. And the Earth observation scientists, as well as oceanographers, meteorologists, particularly interested in this view. This is Super Typhoon Winnie, and we were fortunate enough to pass right over the eye of it. It's a very distinct eye. You could see the blue water through the eye. And also, Super Typhoon is hundreds of miles across. This is probably 300 to 400 miles across that you're looking at. And the way we get these photos, that was video that you saw, but the stills that we're going to show you later are from several different sources. We use a Hasselblad camera. It's a 70mm format, and that does the majority of our Earth ops work. And we had just seen Beamer with one of those cameras. We also, though, carried a Linhof camera, which just brings back gorgeous photos, and that's because the negative on that is a 4-inch by 5-inch shot. And a lot of times, we're busy doing other payloads such as this. Somebody floats up to the window and says, "Hey, look at this target going by. What is this?" And so we kind of scramble for the cameras. In this case, it happened to be the Aurora. The video here is black and white. It doesn't really do it justice, and we've got slides later on to show you, but it was a gorgeous green color that's down the south of Australia, the Southern Lights. I'd like to transition now into the rendezvous day. Here we are on rendezvous morning, getting ready on flight day 10 to go pick up Krista Spas, and it really is a team effort. It takes everybody in the crew is involved, from Kurt doing the manual flying, me doing some flying up front, Steve running a handheld laser. Here we are approaching on Krista Spas, and hours before we get this close to it, we're doing a set of burns to go ahead and phase ourselves in and close in on Krista. From the time we're within about 1,000 feet, it's manual flying, and Kurt at the aft station has it positioned here at the arm. If we were only going to grapple Krista, we would have done it at that point. But along in our flight, we had a detailed test objective, which was to go ahead and simulate a docking on a future space station mission coming up, where Kurt flew Krista right into the payload bay at a very precise rate. And once it was just broke the mold line of the payload bay, backed back out. And to me, it's always amazing that here you've got a 7,000-pound satellite, and we have probably a 250,000-pound at this point orbiter, and we can control that orbiter to a 0.1 foot per second plus or minus 0.03 and very precisely fly it into the grapple.
Well, as you can see, Kurt did a great job flying the orbiter right up around Krista, and he offered just to berth it for us without using the arm at all. And we politely declined that offer, and so Jan took control of the arm. And this is Jan flying in to grapple the Krista Spas satellite. And it's a very gentle maneuver, and here it is ready to get put back into the payload bay. Your eyeballs are essential tools up there in orbit, especially when you're doing robotics operations like we did a lot of in flight. Here's Jan looking out the overhead window, and this is kind of an unusual view where we've got a camera up on the arm looking back down at our crew compartment, this teeny little spot up there in the heavens. And I don't know if you can see Jan looking out the window there, but it's a really important part of doing accurate robotics operations. In the future, however, we're going to have to learn to rely on other sensors other than eyes. We won't always be able to see out of the space station to see our arms. You see targets on the arm here and also targets on our payloads, Krista Spas here. These are for a Canadian-developed synthetic vision system that gives you a computer representation of where the payload is in relative to the payload bay. We brought the Krista Spas right down over the crew cabin on the arm in order to test this system that used these spots as tracking targets. And you can see them here on the telescope of the Krista Spas just about 5 feet over our head. Very dramatic view. We let the sun go down and we kept lights on it, and you can see it even in the dark. We're able to track the targets. And speaking of the sun going down, as a first-time flyer, I found that to be one of the really spectacular sights in orbit. And it comes out even well on video.
We'll have the latest on the space mission in pictures when we return. It may not look like much, but this is a rare glimpse of the Hale-Bopp comet, courtesy of the Shuttle Discovery crew. They beamed down the pictures from a $500,000 ultraviolet telescope, making its maiden voyage. And speaking of pictures from space, Byron Miranda has been studying them and has cooked up a weather forecast. Byron, what's the latest?
I thought you were going to say I was lost in space, Gene. Whoa, no.
Die Besatzung der US-Raumfähre Discovery hat einen neuartigen Roboter getestet. Per Fernsteuerung öffnete ein Greifarm die Tür zur Ladebucht und entnahm dort einen Kasten. Entwickelt wurde dieser Prototyp für die geplante internationale Raumstation Alpha. Der Roboter soll riskante Manöver der Astronauten außerhalb des Raumschiffes auf ein Minimum beschränken.
Astronauts on board the Space Shuttle Discovery are taking close-up pictures of the Hale-Bopp comet. It is still visible from space, as is evidence that there's more to the Earth's atmosphere than most of us imagined. CNN's John Holloman has the latest on what the astronauts are doing.
As Space Shuttle Discovery circles the Earth, there's amazing news about the Earth's atmosphere coming from the Krista Spas satellite probing this planet. The big news from the German-built satellite is that there's lots more water in the Earth's upper atmosphere in the northern part of the planet than people expected. One explanation is that the Earth is getting hit daily by thousands of comets, some the size of a house, which would vaporize into water when they hit the planet's atmosphere. Astronaut Bob Kerbeam is on his first shuttle trip and reports there's a whole lot more going on 150 miles above the Earth.
Most of the experiments are going quite well, actually, Steve. We have, like you said, quite a few experiments. The robotic arm, we did some work on that this morning. Steve and Jan were quite pleased with how that went. And we also have a bunch of other experiments looking at Hale-Bopp, a comet, and various solar system, celestial objects and objects in the solar system, and all those are going well as well.
The main mission of this flight is to test the new Japanese robot arm. That arm experiment is being operated by payload commander Jan Davis, who says it's been working well despite some problems on startup.
We think just the force torque sensor, which tries to take out the forces and torques that were applied to the arm, may have been overreacting a little bit. So we're going to just turn that on at the very last minute when we grapple the box that we're trying to take out of its bracket. And we think it'll work just fine today. We're going to give it another try.
Davis and her arm operating partner Steve Robinson are putting the arm through its paces and will continue to do that for the next couple of days. John Holloman, CNN reporting.
The crew of the U.S. Space Shuttle Discovery is getting on with their mission. They're conducting 24 major scientific experiments and taking new pictures of the Hale-Bopp comet. A short time ago, CNN's John Holloman asked one of the Discovery's crew members exactly how they're getting those pictures.
We have a small telescope that is mounted not outside our crew cabin here back in the payload bay, but right in here, right in this area, about 10 feet to my right. There's a window looking out the side hatch. This is the hatch that we climbed in the shuttle with. And this is a telescope with about a 7-inch diameter mirror, or lens that is. And it attaches to the side hatch and looks out the window. The telescope's about 2.5 feet long and just about the diameter of the window. And we point the whole shuttle. We don't point just the telescope. We point the whole shuttle at the comet. And then it has a very highly intensified CCD camera that's a digital camera on the back of it, and it's enabled to look at the comet in the ultraviolet spectrum. And that is something we cannot do from Earth because the atmosphere protects us Earthlings and everything on the Earth from the ultraviolet rays of the sun, but it also keeps us from learning about the ultraviolet spectrum of astronomical bodies like the comet Hale-Bopp.
The Discovery crew is halfway through an 11-day mission. World News from Washington. We'll be right back in just a moment with all the other news of the day. Stay with us.
Meanwhile, the Space Shuttle Discovery is sending home a flood of information from space, including new evidence that Earth's atmosphere is constantly bombarded by comets. Some scientists have argued for years that thousands of icy comets hit the atmosphere every day. The comet theory is controversial. But now data is coming in from the shuttle showing a huge amount of water about 50 miles above the Earth, more than anyone expected. Comet believers say the water could come from icy comets as big as houses that break up and melt when they hit the upper atmosphere. Solar storms don't happen very often, but when they do, they can knock out a satellite in orbit or cause a power blackout on Earth. Now NASA is launching a new spacecraft that should give us a heads up when a storm on the sun could affect our lives.
It may soon get a lot easier to forecast the impact of solar storms on Earth, thanks to a new spacecraft called the Advanced Composition Explorer, or ACE.
The main thing that we're after here, the number one thing, is to be able to tell ahead of time when major geomagnetic storms. We won't tell all activity, but the major ones is what we're after.
Solar storms occur when bubbles of gas explode from the sun's surface. The eruption sends huge waves of electromagnetic energy washing out toward Earth. Such solar storms can destroy sensitive electronics on orbiting satellites and disrupt power transmission on Earth. Up till now, scientists have been able to observe these solar storms as they develop on the sun, but have not been able to tell how strong they are or how they will affect the Earth. The new spacecraft ACE should change that. The Space Environment Center, run by NOAA, plans to send out regular space weather bulletins to power companies, satellite operators, and others, essentially giving them 1 hour to prepare for a damaging solar storm headed this way. Not much time, but a little notice is better than none at all.
Needless to say, they would love to know a day or two ahead of time. In this particular case, an hour is a useful quantity for that particular customer.
NASA plans to launch the Advanced Composition Explorer spacecraft from Cape Canaveral in Florida, August 24th.
The crew of the U.S. Space Shuttle Discovery has an extra day to relax and enjoy the view from orbit. Concerns of possible fog at the landing site prevented a planned return to Earth on Monday. They'll try again Tuesday with touchdown scheduled for 7:08 a.m. Eastern. CNN will bring you the landing live when it happens.
The U.S. Space Shuttle Discovery is returning to Earth after 12 days in orbit. These are live pictures you're seeing from the Kennedy Space Center in Florida, where Discovery is making its final approach. The 6-member crew was originally scheduled to return on Monday, but weather concerns prompted officials with the U.S. Space Agency NASA to postpone that landing, although the weather did clear up, so they could have landed yesterday. Now, NASA says despite a few glitches, the crew did accomplish all of its goals. Now let's listen to the NASA commentators.
Main gear touchdown. And nose gear touchdown. Discovery's rolling out on runway 33 at the Kennedy Space Center, completing 189 orbits of the Earth while traveling 4.7 million miles. STS-85 is the 23rd mission of Discovery and the 86th in the shuttle program's history.
And another smooth landing for Discovery at the Kennedy Space Center in Florida after 1 day of delay. So that was a total of 12 days on their journey in space. And they did accomplish a great deal of tasks while up there for the 12 days. Most notably, they discovered that the Earth is being bombarded by snowballs constantly.
Well, unfortunately, after 11 days, 20 hours, and 27 minutes, it's time to put the orbiter back on the ground, bring it back home, both the crew and the vehicle back home to the Kennedy Space Center. We started our entry well on the other side of the Earth around south of India, Australia time frame or position. We slowed the orbiter down from its just over 17,000 miles an hour. As you see here, we had an early morning landing, and the glow of the early morning sun through the atmosphere was quite impressive. Approaching overhead, we started a big right-hand turn about 280 degrees to align the orbiter up on final for landing at Kennedy Space Center runway 33. We actually did a new kind of technique on the landing. We used short field speed brake, which is a technique to help control our energy in case we have tailwinds. And we were the first landing ever to use that, and it worked exactly as planned. The orbiter was my first chance to fly the orbiter. It flew very nicely, just like some of the training that we get here at Kennedy or at JSC and at White Sands and Kennedy Space Center. Rolling out on final, approaching the 300-foot point, Kent put the gear down. We crossed the threshold around 230 knots, looking for a touchdown around 195 knots. Right now, Kent's telling me all the right things to do, trying to make sure I get it right the first time. And we touched down about 3,000 foot down the runway. Drag chute came out right away. And just a little bit of different view here as we look down the runway. Again, the drag chute's out and the speed brakes and the vertical tail start opening up to slow us down. As the drag chute comes out, it disreefs, opens up fully to cushion the nose touchdown. And now we roll safely down the runway at Kennedy Space Center after going something over 4.7 million miles.
Main gear touchdown.
They're back. After a one-day extension in orbit caused by worry about the weather in Florida, Space Shuttle Discovery and its crew is back on Earth.
And nose gear touchdown.
As Shuttle Discovery left the Earth, we got to see just what a bumpy ride it is to get into orbit.
1. Booster ignition and liftoff of Discovery on a mission to study planet Earth.
Once they'd had a few hours to get used to weightlessness, the crew got right down to business, grabbing the Krista Spa's science satellite in the cargo bay and gently lifting it into space for 9 days of science research. Astronaut Jan Davis was at the controls.
This is the workstation where we operated the robotic arm, which is a Japanese robotic arm, which will be part of the Japanese arm on the space station. These are the two hand controllers. We have a computer here which also controls the arm, as well as some switches.
When that was done, the scientist astronauts started their next big job, testing a Japanese robot arm that will eventually fly on the International Space Station. Jan Davis and Steve Robinson got to operate the robot arm of the future.
This is the prototype for the small fine arm, as it's called. It will go on the end of a long arm that will go on the Japanese experiment module when the International Space Station is put together up to that point. So this is in a few years from now. And this is the flight test of the small fine arm. So it's quite dexterous. In other words, it can do a lot of things with its joints. It's fairly small. It's only about 1.5 meters to 2 meters long, depending on how you stretch it out. But it has 6 degrees of freedom in the joints. In other words, you can move it around just about like your arm. It's almost hard to talk about the arm without taking your arm out and moving it around, because that's just about what you do with the hand controllers.
Robinson also got to take a look at the Hale-Bopp comet using an infrared telescope, which he pointed out the window on the shuttle's only door. At the end of their stay, the astronauts practiced new maneuvers, which is supposed to make it easier to build the International Space Station starting next year. They grabbed the satellite, bringing its science data, and returned it back to Earth to tell the stories of their fabulous voyage through millions of miles of space. Space Shuttle Atlantis, the next U.S. ship to launch, was just rolled out to the pad in Florida. It will lift off September 25th with astronaut David Wolf on board. He's going to replace Mike Foale on the Russian space station Mir. John Holloman, CNN Atlanta.
We have decided to scrub the launch today. This is due to a shrimp boat that is offshore.
Yes, it was a shrimp boat. Officials scrubbed the launch of a $205 million Delta rocket after a pair of fishing boats drifted into the offshore danger zone. Coast Guard helicopters tried to shoo the boats away, but they couldn't before the rocket's 25-minute-long launch window closed. They'll have to give it another try come Monday. That is, if the shrimp fishermen are done.
Advanced Composition Explorer, looking to study the solar wind. Coming up on
ground lids are burning out.
A NASA rocket blasts into space carrying scientific instruments to study the sun. Onboard cameras provided a spectacular view as the unmanned Delta rocket rose over the Atlantic Ocean. The launch was postponed on Sunday after the crew of a fishing boat failed to clear the area. Shrimp fishermen often work all night and sleep in the day. They may have slept through orders to pull anchor and move.
One, have ignition and liftoff of NASA's Advanced Composition Explorer, looking to study the solar wind. Coming up on
ground lids are burning out. We have good separation on all 6
lids are continuing to form anomaly. They should be burning out in the next
grounds. And separation. We have good separation on all 3 airlit solids.
The first stage is now tumbling.
We have good fairing separation. There appears to be no sign of recontact on the accelerator.
Hello and welcome. I'm Martin Savage. Ann Kellen is on vacation. Would it surprise you to learn that huge rivers flow onto the surface of the sun? They're not made of water, but electrically charged gas. And as Dick Wilson reports, new findings about the sun could shed light on some problems on Earth.
Look at the sun, and what do you see? A churning, swirling ball of gas. Now, new data from the orbiting space telescope SOHO suggests rivers of gases inside the sun may help scientists better predict solar weather.
This is going to enable us to have a much deeper understanding of the dynamics of the sun and is going to herald, I believe, the new era of solar meteorology.
The new data from SOHO indicates the sun experiences complex weather patterns not unlike weather here on Earth. Scientists say rivers of hot electrically charged gases deep inside the sun flow around its equator. Closer to the surface, scientists say the entire outer layer of the sun flows slowly from the equator towards the polar regions. At the poles, researchers found a totally unexpected swirl of gas similar to the jet stream on Earth. And migrating from the poles toward the equator are bands of gases the scientists liken to trade winds. Sunspots appear to form at the edges of these bands in areas where wind shear seems to be taking place.
Where there's shear, you stretch out magnetic fields, and you augment those magnetic fields and produce greater magnetic field intensity, greater magnetic activity. That is where the sunspots first form.
Sunspots are areas of intense solar activity. This is where solar storms brew. Only a few days ago, SOHO spotted an enormous eruption of gas and energy from the sun, in this case pointed away from the Earth. Such solar events, called coronal mass ejections, sent huge waves of electromagnetic energy washing out into the solar system. If they hit Earth, such solar storms can destroy sensitive electronics on satellites and disrupt power transmission on Earth. Scientists hope better understanding of the flow of gases inside the sun will help them predict solar storms more accurately.
Any sort of penetration we could do under the surface to look and see when things are going to emerge might give us more lead time.
Earlier this week, NASA launched a spacecraft called the Advanced Composition Explorer, or ACE, that'll join SOHO in orbit around the sun. ACE will study the composition of the particles that erupt from the sun and should give scientists a better idea about how damaging a solar storm will be once it reaches Earth. Dick Wilson, CNN, reporting.
After we take a break, we'll meet yet another space traveler and find out where on Earth you go to practice for a mission to the moon. NASA's Sojourner rover has been in the limelight this summer, but there's another planetary rover waiting in the wings. The vehicle called Nomad is practicing its moves in a landscape chosen because of its resemblance to the moon. Ann Kellen has more.
A moonwalk on Earth. That's what the robot Nomad is getting in the Rocky Desert in Atacama, Chile. Nomad is a prototype of the robots that will explore the surface of the moon and other planets of the solar system in the near future. For now, it's rolling on the sandy South American landscape, showing off its technological prowess. Nomad carries state-of-the-art equipment for mobility, imaging, and space communications. Nomad is controlled from Carnegie Mellon University in Pittsburgh, Pennsylvania, more than 5,000 miles away. Engineers at Mission Control guide it with the help of a 360-degree panoramic view taken by the Nomad's camera. What is now an intercontinental remote control will become an interplanetary one in the future. Alex Fossil and 8 other specialists from Carnegie Mellon came to the Atacama Desert to test Nomad's ability to share its experiences.
The images are compressed and sent through satellite links, in this case to Santiago and Pittsburgh. People can explore the terrain and feel like they are practically in the middle of the desert. This is what we are trying to test, basically, the sensation of being in the place, even if you are in a remote location.
And Nomad can take care of itself in hostile environments. Engineers have given the robot something akin to an immune system. It allows Nomad to ignore human commands that threaten its safety. Mark Malmone designed the system.
Well, Nomad has many cameras on it, and 6 of the cameras on Nomad are used by a navigation system. So these cameras work, they take a new picture each second, and there's a computer inside Nomad that processes it. And the images are processed, and Nomad can see where there are obstacles in front of it, and it will automatically steer around the obstacle.
Besides being smart, Nomad is heavy duty.
Our baseline for this type of robot is something like 1 or 2 year mission. What we'd like to do is have it on the moon and visit all the different sites that Apollo has landed on the moon, and just see what we could find there. Sort of a tour of the moon.
Eric Rollins designed the mechanical systems for the Nomad. When he turns 31, he'll be able to see the robot in action on the moon. That's about 3 years away. A great birthday present he'll share with millions on Earth. Ann Kellen, CNN reporting.
It's sleek and stealthy, and aviation experts say it's the shape of things to come.
We are beginning to show what the fighter aircraft of the future will look like.
This is the X-36, a tailless research aircraft developed by NASA Ames Research Center and McDonnell Douglas. Researchers designed it without a tail to increase agility and to help the craft avoid detection by radar.
It helps with survivability, and at least that's the terminology that we use when the pilots go out and do the mission and they come back home. They get shot down less.
Usually a tail gives a plane what engineers call directional stability, but the X-36 has no tail. Instead,
the X-36 has aerodynamic control surfaces on the trailing edge of the wing that we call split ailerons that are used for directional control. It also has a vectoring nozzle that's used for directional control. It's a nozzle that can point the thrust of the engine in different directions, up and down and left and right, as needed to provide stability or control for the airplane.
Researchers expect the X-36 to be more maneuverable and more agile than today's fighters. The tailless design reduces weight and drag. The X-36 is remotely controlled by a pilot on the ground. There's a video camera in the nose of the aircraft. The pilot steers from a virtual cockpit.
And he has a stick and he has rudder pedals just like he was sitting in the cockpit of the airplane. And if he pulls the stick back, the airplane goes up. If he pushes it forward, it goes down. If he pulls the stick to the right, it rolls to the right, just like any other aircraft.
Rod Bailey says unmanned flights will become more and more important to the military.
The big thing is what is on the horizon today is unmanned aircraft. That's where the big interest is going. And it allows you to do a lot of things with an aircraft that you can't do with a pilot in there.
The X-36 made its first flight this summer at NASA's Dryden Flight Research Center.
Nice takeoff, good performance. Handling was great, and the landing was also very nice and just like we had simulated and practiced.
More tests are underway for the prototype, a scaled-down version about 18 feet long, 3 feet high, and 10 feet wide from wingtip to wingtip. The X-36 final design could be a lot bigger.
Oh, it would depend upon whether it was a piloted aircraft or not and what the mission was. The size of an aircraft is determined by its mission, how far it has to fly and what it has to carry.
But experts expect big things from the X-36.
This tailless technology will have many applications in certainly in military arenas, and also we expect there to be spin-offs for commercial applications.
I think when you saw this airplane lift off, you saw the shape of airplanes to come. Probably 20, 25 years from now, this will be standard military technology for this kind of aircraft. To be highly maneuverable, agile, and have low signature.
The plane's designers say rapid prototyping kept costs down on the X-36. The price tag to design, build, and test two of the aircraft, $17 million, less than half the cost of just one of the Pentagon's new F-22 fighters. David George, CNN, Future Watch.
He's not a Hollywood stuntman or a human crash test dummy, so why is this man tied to a treadmill walking sideways? He's part of a team at Penn State University trying to simulate the weightlessness of space.
We call it a zero-gravity simulator to suspend the important parts of the body by cords which offer a load equal and opposite to the weight. So when you are lying there on this device, you don't sense the weight of any of your major body segments. And also, as you move the limbs, the device moves with you so that you can feel that you're actually moving in weightlessness.
One key goal for the team is to learn how much exercise is enough for the astronauts to keep their bones from losing too much calcium during extended space flights. Studies of returning astronauts show a loss of bone material after just a few days in space. Scientists have found that exercise slows down the rate of calcium loss and keeps bones strong. Treadmills like this are a great source of exercise here on Earth. They help keep both muscles and bones in good shape. But the problem in space is weightlessness. One solution is to build an exercise device that holds the feet to the treadmill.
And this harness that we're putting on him now is used to tether him to the treadmill, and this is what the astronauts would wear.
Once the subject is strapped in and suspended, researchers monitor his reactions while running on the vertical treadmill.
I think after a while you get used to it, but at the beginning it feels really strange.
The Penn State research helped NASA astronauts test the latest version of the world's most expensive treadmill. It literally floats in the cabin.
They mounted it in the middeck, and then all three of them exercised on the treadmill while we were measuring to see whether indeed you could walk and run on this floating structure, which has never been done before.
Back on Earth, there are important applications for the lessons learned on this mini gym in space.
Once we understand why people lose bone in space, it's going to give us a very interesting perspective on why you lose bone on Earth. And as we know, for both men and women, the loss of bone mineral, which makes bones more brittle in older age, is a very, very significant health problem.
And a critical health problem for space travelers. Now that the shuttle treadmill tests are over, the next stop is to test it on the International Space Station. Its longer missions will make bone preservation an important issue for the astronauts and exercise a must. Dick Wilson, CNN, State College, Pennsylvania.
The weightless treadmill idea in itself is not new. Cosmonauts and astronauts living aboard the Russian space station Mir exercise for several hours every day using a treadmill and stationary bicycle.
Amerikanischer Tarnkappenbomber während einer Flugschau in ein Wohngebiet gestürzt. Durch eine Explosion wurde die Maschine buchstäblich zerrissen. Der Pilot konnte sich rechtzeitig mit dem Schleudersitz retten. 4 Anwohner wurden verletzt, mehrere Häuser zerstört. Bislang ist die Absturzursache noch unklar.
The United States Air Force is grounding all combat jets on Monday to conduct safety inspections. Friday, an Air Force B-1B bomber went down in the U.S. state of Montana, killing all 4 crew members. It is the 6th U.S. military plane to crash in the past week alone. Well, in spite of the accidents, the Navy is putting on one of its largest air shows at Virginia Beach, Virginia. Louise Schiavone is at the Neptune Festival Air Show. She joins us now. Louise?
Well, this is a classic example of how the show must go on. This is called the Neptune Festival Air Show. It's the 39th of its kind. They happen every year at this time. It's a huge festival. Thousands of people come here. There are 20 acts. This is the home base for all of the F-14 jets in the Navy. Now, behind me, you can see an Air Force B-1. This B-1 is not going to be flying, and we have heard that although a B-2 bomber was supposed to be flying during this show, it is not going to be flying. We're going to be able to firm that up for you in a little while, but right now there is some doubt as to whether or not any of the B-1 or B-2 bombers are going to fly. All of the squadrons here at some point in the coming week are going to comply with the order from the Secretary of Defense that there be a stand down. They're going to take 24 hours to review every facet of operating the planes here. They say that safety is paramount every day. That's their motto. In fact, Lloyd's of London has ranked the deck of a Navy carrier the most dangerous 4.5 acres in the world. We spoke with the commanding officer of NAS Oceana here in Virginia Beach, Virginia, Captain Eric Benson. He says, yes, of course they are concerned about safety. There are no exceptions. There are no excuses. But let's face it, this is a dangerous business.
Well, this is an inherently dangerous business, but we have established procedures that have enabled us to maintain an accident-free air show here at Oceana. There are hundreds of air shows annually, and while the crashes are very tragic, certainly, and spectacular, they're relatively infrequent.
Flying here today are not just Navy planes, but also U.S. Air Force planes and planes from the Canadian Air Force. This has been going on all weekend, and so far it's a very festive occasion, a real sort of carnival atmosphere, very interesting maneuvers, aerobatics, and a very enthusiastic crowd.
To the point on the crashes, Louise, the U.S. military has complained in public at times that they're being asked to do more with less. They've had to face, like many other government departments, a cutback in funding. Is anyone publicly linking these crashes to such cutbacks?
No, you know, it's very interesting. There really hasn't been any complaining about the kind of money that they're given to operate. What they are doing is boasting about what they consider to be a very safe year. Last year, there were 21 accidents involving Navy planes. This year, there have been only 14. The year ends at the end of what they call the fiscal year, which ends at the end of September. So they have actually been having a very good and safe year. Of course, there's been this cluster of accidents, but overall, in fact, in the military, all of the planes have had a very good year.
Well, as we look at the air show, that B-1 or B-2 behind you, and having seen those FA-18 Hornets in the sky, what's the advantage, the real purpose, if you will, of having these kinds of military air shows?
Well, the purpose of the air show is, first of all, to demonstrate the spectacular capability of these planes, to demonstrate that the United States does have military pilots who can control these planes, who can use these to their maximum potential. Back to you.
Louise Schiavone reporting to us there from Virginia Beach, Virginia. Yet another air show as the U.S. military struggles to come to grips with a series of deadly accidents involving its planes.
Im US-Staat Montana stürzte jetzt ein B-1-Bomber der Luftwaffe ab. Dabei wurden alle 4 Besatzungsmitglieder getötet. Es ist bereits der 6. Absturz eines US-Militärflugzeugs innerhalb einer Woche. Aus New York berichtet Ralf Hogestraat.
Experten und Offizielle waren auch am Morgen nach dem letzten Absturz noch ratlos.
Der B-1 Langstreckenbomber, hier Archivaufnahmen, war auf einem normalen Trainingsflug über dem US-Bundesstaat Montana gewesen. Bomben hatte das umgerechnet 380 Millionen Mark teure Flugzeug nicht an Bord. Alle 4 Besatzungsmitglieder kamen ums Leben. Dabei hatten seit Mitte dieser Woche alle Teilstreitkräfte der US-Armee die Sicherheitsregeln für ihren Flugbetrieb genau untersucht. Das ist die Grausamkeit der Statistik. Eigentlich war unsere Absturzbilanz dieses Jahr besser als je zuvor, aber jetzt häuft es sich einfach. Begonnen hatte die Unglücksserie am vergangenen Wochenende, als vor Namibia ein amerikanisches Transportflugzeug dieses Types mit einer deutschen Militärmaschine zusammenstieß. Dann stürzte während einer Flugshow ein Tarnkappenbomber spektakulär ab. Die Piloten zweier F-16-Jäger, die vor New Jersey zusammenstießen, konnten zwar gerettet werden, aber insgesamt sind bei den Abstürzen bislang 38 Menschen ums Leben gekommen. Mit einem Flugverbot in der kommenden Woche will das Pentagon jetzt untersuchen, ob Routinefehler oder mangelndes Training die Abstürze verursacht haben.
Und hier ist Wolfgang Klein.
Guten Abend, meine Damen und Herren. Es ist wie verhext, den US-Amerikanern fallen zurzeit die Kampfflugzeuge in Serie vom Himmel. Bei einem Trainingsflug stürzte in der vergangenen Nacht ein B-1-Bomber ab, Gottlob ohne Bomben an Bord. Alle 4 Besatzungsmitglieder sind tot. Das 6. Unglück in nur einer Woche. Jens-Uwe Meyer.
Dieses Flugzeug gilt als eines der besten und sichersten der amerikanischen Luftwaffe. Der B-1-Bomber, Stückpreis mehr als 200 Millionen US-Dollar. Warum die Maschine bei einem Routineflug im Bundesstaat Montana abstürzte, ist noch immer unklar. Augenzeugen berichteten, das Flugzeug sei plötzlich verschwunden, dann sei eine schwarze Rauchwolke aufgestiegen. Erst am Donnerstag hatte die amerikanische Luftwaffe ihren 50. Geburtstag und zugleich eines der sichersten Jahre in ihrer Geschichte gefeiert. In diesem Jahr hat die Armee insgesamt 55 Flugzeuge bei Abstürzen verloren. Vergangenes Jahr waren es 64. Doch das freut allenfalls die Statistiker. Für Montag hat die Luftwaffe alle Trainingsflüge abgesagt. Auch wenn die Abstürze nicht miteinander zusammenhängen, die amerikanische Luftwaffe will eine Ruhepause einlegen. Einen Tag lang soll sich alles um das Thema Sicherheit drehen. Vielleicht, so die Hoffnung der Militärs, kann die rätselhafte Absturzserie damit beendet werden.
The signs of El Nino continue to build along the coast of California. Big waves have been spawned by former Hurricane Linda, which experts say was strengthened by El Nino.
The fact that it got so far north before beginning to lose energy is definitely influenced by the warm water from the El Nino.
Spanish for the boy child, El Nino is a warming of the Pacific off Peru and Ecuador. The latest satellite images from the Jet Propulsion Laboratory in Pasadena, California, show a very strong El Nino is firmly in place.
We saw this as early as May. It's persisted through June, July, and into August, actually intensified. Based on the comparisons with the past data, this is potentially the event of the century.
The information is significant because El Nino can affect weather worldwide. The condition in 1982 and 83 was a strong one and produced big winter storms like this, which did tremendous damage along the west coast of the U.S. Now, advanced computers and satellite monitoring allowed scientists to begin forecasting the current El Nino and a stormy winter much earlier. The warnings are taken seriously. Los Angeles County created these large berms along many beaches to prepare for Hurricane Linda and other storms forecast for the winter. It's done so before, but not this early. The weather predictions based on El Nino are not a sure thing. Mother Nature has fooled the forecasters before. But one thing appears to be certain, El Nino is rapidly becoming one of the most studied weather patterns ever. Jim Hill, CNN, Pasadena, California.
Ist eine europäische Ariane-Trägerrakete ins All gestartet. Gegen 2 Uhr hob die Ariane 4 ab und brachte einen 3,5 Tonnen schweren Fernmeldesatelliten in seine Umlaufbahn. Er wurde für den Telefonverkehr und für Fernsehverbindungen zwischen Europa und den USA entwickelt. Ariane-Raketen sind seit 18 Jahren im Einsatz. Nur 8-mal gab es Fehlschläge.
Jubiläumsflug für die Ariane vom Weltraumbahnhof Kourou in französisch-Guyana startete zum 100. Mal eine europäische Trägerrakete ins All. Sie brachte einen Kommunikationssatelliten in seine Umlaufbahn. Seit dem ersten Flug einer Ariane gab es nur 8 Fehlstarts, zuletzt beim Jungfernflug des neuen Modells Ariane 5 im Juni 1996.
der Nacht zum 100. Mal ins All gestartet. Um 2 Uhr deutscher Zeit hob die Rakete mit einem Bilderbuchstart vom Weltraumbahnhof Kourou zu ihrem Jubiläumsflug ab. 20 Minuten später setzte die Ariane einen amerikanischen Kommunikationssatelliten in der Umlaufbahn aus. Er soll in den nächsten 15 Jahren Telefon- und Fernsehverbindungen über dem Atlantik herstellen. Mehr über das Ariane-Jubiläum gleich hier bei uns in Punkt 7. Zum 100. Mal hob die europäische Trägerrakete Ariane vom Weltraumbahnhof in Kourou ab. 20 Minuten später setzte sie planmäßig ihre Fracht ab, einen amerikanischen Satelliten. Die Betreibergesellschaft Ariane Space hat seit dem ersten Ariane-Start 1979 aus dem Wagnis-Weltraumflug ein lukratives und routiniertes Geschäft gemacht. Nur vor dem Jubiläumsstart, da waren alle ein bisschen nervös, denn gerade jetzt können sich die europäischen Raketenbauer keinen Fehlschlag erlauben. Ralf Benkö sagt Ihnen, warum.
Es ist immer wieder ein Spiel mit dem Feuer. Leicht gerät die gewaltige Raketenenergie außer Kontrolle. Beim 100. Start heute Nacht jedoch ist alles planmäßig verlaufen. Der 93. gelungene Flug in der Ariane-Geschichte. Eine Erfolgsserie, was die Ariane 4 angeht. Nach wie vor beschäftigen die Raketenmänner am roten Knopf jedoch die Bilder aus dem Juni vergangenen Jahres vom Start ihrer neuen Superrakete Ariane 5. Ein Fehlschlag, der die europäischen Ingenieure in Kourou weit zurückgeworfen hat.
Natürlich waren wir alle schockiert, aber die Motivation ist wieder da und wir arbeiten alle sehr stark.
Beim Untersuchen des Wracks stellen sie fest, ein Softwarefehler in der Steuerung der Ariane 5 ist damals schuld gewesen. Sie war vor ihrem ersten Start wohl nicht genug getestet worden. Das holen die Weltraumtechniker jetzt nach. Bei der zweiten Ariane 5. Einiges hängt davon ab. Nur sie ist stark genug, um die großen Kommunikationssatelliten der Zukunft ins All zu schießen und Teile der internationalen Raumstation. Die Konkurrenz durch andere Raketenbetreiber wird auch immer größer. Was steht auf dem Spiel beim nächsten Start der Ariane 5?
Ich würde sagen, die ganze europäische Kooperation in Technologie.
Der Weltraumbahnhof im Urwald wird nur mit der neuen Superrakete auch das Tor zum All der Zukunft sein. Ihr zweiter Startversuch steht in einigen Wochen bevor. Eine Bewährungsprobe. Die alte Ariane 4, deren Tage künftig gezählt sind, ist spätestens mit ihrem Jubiläumsstart der vergangenen Nacht schon in die Weltraumgeschichte eingegangen.
Während die amerikanische und russische Raumfahrt mit bemannten Unternehmungen im Blickpunkt steht, haben sich die Europäer die Spitzenposition beim Transport von Nutzlasten in den Weltraum gesichert. 14 Staaten gehören der Europäischen Raumfahrtagentur ESA an. Am Bau der Ariane sind auch 2 Werke der deutschen DASA maßgeblich beteiligt. Auf dem Erfolgsweg waren auch Probleme zu überwinden.
Am Anfang natürlich hat man schon gemerkt, die verschiedenen Mentalitäten. Aber mittlerweile mit der Zeit, wir arbeiten noch seit 15 Jahren zusammen und das klappt hervorragend.
Voller Hoffnung wird der nächste Start der größeren Ariane 5 Anfang Oktober erwartet. Beim Jungfernflug im Sommer vergangenen Jahres musste diese allerdings wegen Datenfehlern im Navigationssystem kurz nach dem Start gesprengt werden.
Jubiläumsstart. Vom südamerikanischen Weltraumbahnhof Kourou aus ist zum 100. Mal eine Ariane-Rakete gestartet worden. Die Europäische Weltraumagentur ESA bringt mit diesem Flug einen Satelliten des internationalen Telekommunikationskonsortiums Intelsat ins All. Er soll die Sprachdaten- und Fernsehübertragung im atlantischen Raum unterstützen.
Das sind die ersten feuchten Auswirkungen von El Niño, die die Küste von Mexiko erreichten. Hurrikan Nora setzte ganz Baja California unter Wasser. 1000 Kilometer weiter nördlich im amerikanischen Kalifornien freuen sich die Surfer noch über El Niño, weil die Brandung dieses Jahr ungewöhnlich wild ist. Andere bereiten sich eher auf einen langen und stürmischen Winter vor. Künstliche Sanddünen werden gebaut, um die Küsten vor den erwarteten Stürmen zu schützen. Dachdecker sind hier derzeit besonders gefragt. Die Häuser des sonnenverwöhnten südlichen Kaliforniens werden regendicht gemacht. An besonders empfindlichen Küstenstreifen werden schon einmal Sandsäcke gesammelt, um sich auf das Schlimmste vorzubereiten. Es sieht so aus, als ob uns ein Wetterphänomen von noch nie dagewesener Stärke bevorsteht. Seit Jahresbeginn beobachten die Wissenschaftler per Satellit, wie das Wasser im Pazifik immer wärmer wird und Amerikas Westküste immer stärker aufheizt. El Niño scheint das ganze Gefüge der Natur durcheinander zu bringen. NASA-Spezialgeräte zeigen, wie das Plankton an der Ostküste geradezu explodiert. Und vor Kanadas Westküste tauchen immer mehr tropische Fische auf. Beim El Niño der 80er Jahre folgten den Fischen dann die Stürme, die ganze Küstenstriche vernichteten.
Die Europäische Raumfahrtbehörde ESA hatte in der vergangenen Nacht Grund zum Feiern. Zum 100. Mal startete von Kourou in Französisch-Guyana eine Ariane-Rakete ins All und setzte dort einen Fernmeldesatelliten aus. Seit dem ersten Start im Dezember 1979 gab es nur 8 Fehlschläge. Ralf Benke mit weiteren Einzelheiten.
Sie spielen jedes Mal wieder mit dem Feuer. Leichtgeräte, gewaltige Raketenenergie außer Kontrolle. Die Ingenieure am roten Knopf dürfen sich keinen Fehler erlauben. Der Jubiläumsstart vergangene Nacht der Ariane 4 ist gelungen. Eigentlich Grund zum Aufatmen. Doch dieser Fehlstart des größeren Nachfolgemodells Ariane 5 im vergangenen Jahr wirkt bei den europäischen Raketenbauern heute immer noch nach.
Natürlich waren wir alle schockiert, aber die Motivation ist wieder da und wir arbeiten alle sehr stark.
Nur die neue Superrakete ist kraftvoll genug, um künftige Großsatelliten zu befördern. Vor dem zweiten Startversuch, geplant ab dem 30. September, haben die Ingenieure die Überreste des ersten untersucht, einen Fehler in der Steuerung entdeckt, verbessert und sämtliche Systeme noch einmal durchgecheckt. Nach einem letzten Test auf der Startrampe muss der Countdown jetzt aber doch noch weiter in den Oktober verschoben werden. Es steht viel auf dem Spiel.
Ich würde sagen, die ganze europäische Kooperation in Technologie.
Denn Amerikaner und Russen versuchen demnächst Raketen von schwimmenden Plattformen aus zu starten, von günstigeren Positionen der Welt als die Europäer. Von Kourou aus hat die alte Ariane 4 zwar bis zum heutigen Jubiläum die Marktführerschaft erflogen, um ihren Weg in die Zukunft müssen die Europäer im Augenblick aber dennoch weiter bangen.
Erfolgreiches Jubiläum für die europäische Raumfahrt. Zum 100. Mal hob eine Ariane-Rakete vom Weltraumbahnhof Kourou in Französisch-Guyana ab. Der europäischen Betreibergesellschaft Ariane Space gehören 53 Teilhaber an, darunter auch die deutsche DASA und MAN.
9, 8, Kurz vor 2 Uhr heute Nacht war das Himmelsfenster offen für den 100., den Jubiläumsflug der europäischen Trägerrakete. Ohne Komplikationen hob Ariane 4 in Kourou ab, um kurz darauf den insgesamt 135. Satelliten auszusetzen. Erleichterung und Grund zum Feiern an vielen Orten Europas. Das Ariane-Programm sichert Arbeitsplätze bei 240 Unternehmen, darunter 2000 in Deutschland. Mit einem Flop hatte das Ganze am 15. Dezember 1979 begonnen. Die Triebwerke zündeten zwar, doch die erste Rakete blieb am Boden. 2 Tage später, der nächste Versuch bringt den Durchbruch. Während Amerikaner und Russen mit bemannten Raumfahrtunternehmen im Blickpunkt bleiben, erobern die Europäer mit Ariane die Spitzenposition beim Transport von Satelliten und anderen Nutzlasten in den Weltraum. Mittlerweile laufen in Kourou die letzten Vorbereitungen für den Start der leistungsstärkeren Ariane 5. Ein Sorgenkind. Beim Jungfernflug im Sommer vergangenen Jahres musste diese wegen Fehlern im Navigationssystem gleich nach dem Start gesprengt werden. Dabei gingen Nachrichtensatelliten im Wert von 800 Millionen Mark verloren. Vom Erfolg der Ariane 5 hängt die künftige Rolle der europäischen Raumfahrt ab.
These images of the Chesapeake Bay were taken by a sensor named SeaWIFS from a satellite that orbits Earth every 90 minutes. SeaWIFS penetrates the Earth's atmosphere to get images of microscopic plant life several feet underwater. That's never been possible before. So for the first time, scientists are getting a global view of ocean life.
I really believe it's going to revolutionize the way that we observe the Earth, not just the oceans, but the land, and the combination of the two, essentially life on Earth as a whole.
In these images, bright red indicates areas where oceans are rich with microscopic plants called phytoplankton, and the blue and green areas have less phytoplankton. Since phytoplanktons are considered the grasses of the ocean, scientists say they're a good barometer for the health of marine life in general. Astronaut Mary Cleave joined the SeaWIFS project after observing Earth from the Space Shuttle. In the 4 years between her first and second mission, the changes she noticed scared her.
Because when I looked down at the Earth, I could really easily see the changes that human activity were making, and that really concerned me.
SeaWIFS is designed to monitor those changes. This is what the coast of Africa looks like now. Scientists want to know how the colors may change, if pollution will have an effect on sea life, or intense weather, like El Niño.
One of the things that we hope to be able to do over the next few months as this El Niño develops is to actually monitor how El Niño and the physical processes in the ocean affect the biology El Nino has major impacts on fisheries. Fisheries collapse off the coast of Peru. Fisheries have gone from 10 million metric tons to 1 million metric tons a year as a result of El Nino.
According to Feldman, sea whiffs will help scientists pinpoint areas conducive to the spread of water-bearing diseases like cholera or typhoid, as well as understand conditions that breed fish-eating organisms like Listeria. The possibilities, he says, are endless. And sea whiffs images are now available on the World Wide Web for all of us to see. According to NASA, we'll be able to access those images within minutes of them being processed in space and fed to Earth. Ann Kellen, CNN, Atlanta.
Doch Geheimnisse gibt es auch auf der Erde noch genug. Und deshalb sahen am 7. August dieses Jahres die Wissenschaftler mit großer Spannung dem Start der Raumfähre Discovery entgegen. Im Gepäck hatte die Discovery den deutschen Satelliten Christa-Spass 2. SPAS steht für Shuttle Pellet Satellite, also Satellitenplattform für den Shuttle. 1983, bei diesem erst 7. Flug einer Raumfähre überhaupt, flog der erste wiederverwendbare Satellit der Welt zum ersten Mal. Noch nie vorher hatten Astronauten einen Satelliten ausgesetzt und später wieder eingefangen. Erst wenige Jahre zuvor hatte die NASA die Industrie weltweit aufgefordert, Vorschläge zu machen zur Nutzung des neuen Systems Space Shuttle. Und dieser Raumorbiter, der wie ein Flugzeug wieder landen konnte, bot sich natürlich auch an für Nutzlasten, die man wieder zur Erde bringen wollte. Aus der geöffneten Ladebucht der Raumfähre Challenger trat Spass 01, ein von Messerschmitt Bölkow-Blum entwickelter Vorläufer der heutigen Astrospace-Plattform, seinen ersten 4-stündigen Freiflug an. Premiere damals auch für die Astronauten an Bord der Challenger, die den Satelliten in seine Position brachten und dann losließen. Entstanden war dieser Satellit aus einem innerdeutschen Wettbewerb zwischen MBB und Erno in Bremen. Heute übrigens beide unter dem Dach der Daimler-Benz Aerospace, DASA. Konrad Moritz, der geistige Vater des Spass, erinnert sich.
Es war eigentlich eine ganz eigentümliche Geschichte. Wir hatten uns bemüht, den Space Lab-Auftrag zu bekommen und unsere damalige Konkurrenzfirma Erno in Bremen hat ihn nun erhalten und da waren wir ziemlich sauer. Dann hieß es, wir machen die Space Lab-Nutzung in München und als es dann soweit war, hieß es, ja, das machen am besten die, die Space Lab gebaut haben. Und da saß ich mit meinem Chef in Bonn im China-Restaurant und ich sagte, sowas darf uns nicht nochmal passieren. Wir sollten was machen, was in unseren Händen bleibt.
Bis heute hat Spock die Verantwortung für die Astrospace-Missionen. Nicht der mit den Ohren, sondern das Space Payload Operations Center, ein eigens installiertes deutsches Kontrollzentrum direkt am Cape Canaveral. Von hier aus wird Astrospace gesteuert. Hier laufen alle Daten auf.
Spock ist für uns außerordentlich wichtig. Es ist nämlich so, ein kompliziertes Gerät wie der Astrospace verlangt sehr große Kenntnisse, wie er operiert wird. Bei normalen Satelliten wird das Know-how, das übertragen von dem Engineering-Team, die den Satelliten gebaut hat, auf das Operations-Team, die den Satelliten betreibt. Das ist natürlich richtig, wenn es über Monate und Jahre geht.
Die Space-Missionen aber sind als Shuttle-Missionen immer auf höchstens 3 Wochen ausgelegt. So wie Christa-Spass 2, die an diesem Morgen des 7. August auf ihren Einsatz wartet. Das Wetter ist lange ein bisschen wackelig, aber schließlich hat die Unsicherheit ein Ende. Alle Systeme sind auf Go. Astrospace kann auf seine jetzt 4. Reise gehen. Die Startsequenz selbst verläuft dann völlig reibungslos. Zeit, noch ein paar Souvenirs zu kaufen. Nach einem erfolgreichen Start sind die alle weg und nach einem Fehlstart erst recht. Aber die große Countdown-Uhr bleibt heute nicht mehr stehen. Pünktlich um 10:44 Uhr erfolgt der Start.
5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery on mission to space planet Earth.
Die Discovery ist oben, aber das ist erst der erste Schritt. Was ist mit den hochfeinen wissenschaftlichen Instrumenten, die da auf 2000 Tonnen Sprengstoff ins All geschossen wurden? Die deutschen Space-Experten müssen auf die Meldung über den Zustand von Christa-Space in diesem Moment noch über 180 Minuten warten.
Für uns kommt natürlich dann in etwa 3 Stunden der zweite große Moment, dann werden wir eingeschaltet und da gibt es immer so ein Nightmare, wie heißt es auf Deutsch, Albtraum, dass nun der Bildschirm schwarz bleibt, wenn man einschaltet.
Und tatsächlich beginnt die Christa-Spaß-Mission, die neue Erkenntnisse über die mittlere Erdatmosphäre liefern soll, unruhig. Die NASA hat Probleme, die Funkkommandos zum Satelliten zu übermitteln. Der Fahrplan gerät ins Wanken. Das Abkoppeln von Christa-Spaß, das sogenannte Release, gerät in Gefahr. Im Spock kann man jetzt nur warten.
Das Release ist das Wesentliche. Wenn das nicht um 5:45 passiert, dann müssen wir den ganzen Fahrplan um einen Tag verschieben. Sie werden es nicht glauben. Der Grund ist, dass die Astronauten ins Bett müssen.
Und gerade wegen dieses minutiös geplanten Shuttle-Zeitplans ist es für den Satelliten Christa-Spaß immens wichtig, vom Greifarm wegzukommen. Denn die Hoffnungen, die man auf den Freiflug des kryogenen Infrarotspektrometers setzt, das ist der komplette Name von Christa, die sind groß. Die Untersuchungen der Vorgänge in der Erdatmosphäre zwischen 10 und 100 Kilometer Höhe sollen Erklärungen ermöglichen zum Verständnis von Erscheinungen wie dem Ozonloch oder dem Treibhauseffekt. Zwar hatte die Satellitenplattform Astrospace das Umweltteleskop Christa schon vor 3 Jahren einmal Huckepack genommen, um Messungen der Atmosphäre durchzuführen. Doch Christa-Space 2 hat 10-mal empfindlichere Messgeräte an Bord. Dann endlich. Genau um 5:45 ist alles gut. Christa-Space wird vom Shuttle abgetrennt. Und der deutsche Recycle-Satellit hat sich wieder einmal bezahlt gemacht. Übrigens nicht nur für die Wissenschaftler. Natürlich spart so ein Gebrauchssatellit auch viel Geld. Kostete der erste Flug noch rund 115 Millionen Mark, so waren es beim zweiten nur noch 40 Millionen. Und inzwischen sind die Kosten gesenkt pro Flugeinsatz auf rund 20 Millionen Mark. In der Satellitentechnik ein Spottpreis. Astrospace hat mit Christa 1 und 2 nicht nur Missionen zum Planeten Erde unternommen. Auch in der Erforschung anderer Planeten und Sterne hat der deutsche Forschungssatellit unter dem Namen Orpheus-Space schon eine wichtige Rolle gespielt. 1993 und 96 sammelte das Teleskop Informationen über Gaswolken und Sterne. Dabei wurden 400 Ziele im fernen Raum angepeilt. Mehr als diese 4 Missionen waren zunächst nicht geplant. Aber die Anzeichen mehren sich, dass der Astrospace noch öfter fliegen wird.
Natürlich gehört dazu, dass auch hier im wissenschaftlichen Bereich entsprechende Budgets von der deutschen Seite zur Verfügung gestellt werden. Und ich glaube, dass wir in diesem Bereich auch gerade mit einem wiederverwendbaren Satelliten, der in der Tat ja ausgesetzt wird und dann wieder zurückkehrt zur Erde, einen sehr kostengünstigen Träger haben, der in der Tat konkurrenzlos ist. Und deshalb glauben wir, dass es also auch in der Zukunft weitergehen wird.
Und das heißt, der Space könnte von dem Space Shuttle, hier sein Einbau in die Ladebucht der Discovery, unabhängig werden. An der im kommenden Jahr startenden Internationalen Space Station ISS könnte ein Space, leicht modifiziert, für den Dauerbetrieb angedockt werden. Die ISS gilt als das Weltraumprojekt der kommenden Jahre.
Es sind natürlich heute schon entsprechende Unteraufträge vergeben hier innerhalb der deutschen Industrie und wir haben hier ganz wichtige Module an der Space Station zu liefern und deshalb ist es ein sehr wichtiges Element für die Zukunft, um nicht auch international hier in eine Isolation zu geraten.
Die Zusammenarbeit im All soll durch die internationale Weltallstation noch intensiver werden. 1998 soll ihr Aufbau beginnen und dann hat auch die russische Station Mir bald ausgedient. Inzwischen so sehr nach Routine aussieht. Im Kennedy Space Center in Florida ist das Unglaubliche des Abenteuers Raumfahrt immer noch spürbar. Und hier im Space Shop ist es auch gut zu verkaufen. Bei allen Leistungen, die die europäische und deutsche Raumfahrt in diesem Jahr hervorgebracht hat, die Leichtigkeit der Amerikaner im Umgang mit dem Weltall bleibt wohl unerreicht. Dabei ist es doch eigentlich ganz einfach, von der Schwerelosigkeit immer wieder fasziniert zu sein.
Continuing to go well out at the launch pad. The final inspection team is making their way up and down the launch tower, looking for any loose items or any ice or frost formation. They do wear the bright orange suits so that we can keep track of the crew as they wander around the launch pad. And we have live pictures of the flight crew and crew quarters. We've got Commander Kurt Brown, who's just walked into the suit-up room following the weather briefing. This is his 4th flight, and he has overall responsibility for commanding the flight. This will be his first flight as commander. He served as pilot of 3 previous missions on STS-92 in 1992, 94, and 96. Kent Rominger. As pilot, he will assist Brown at the flight controls. This will be his 3rd flight and his birthday today. He's 41 years old. He will also be assisting Commander during the rendezvous and retrieval of the Krista Space payload, and will also be involved in several payloads, including the solid surface combustion experiment. We have Canadian astronaut Bjarne Tryggvason making his first flight on the shuttle today. Across the room we have the mission specialist. We've got Jan Davis. She's making her 3rd flight today. She's the payload commander with overall responsibility of servicing tasks. She will operate the robot arm to deploy and retrieve the German Krista Space payload. And we have mission specialist Robert Kirby making his 1st flight today on the shuttle. He serves as flight engineer and will assist the commander and pilot with ascent and re-entry checklists and in monitoring all vehicle systems. And we have mission specialist Stephen Robinson. This will be his 1st flight. He is the prime mission specialist for the Krista Space payload, and he will work with Jan Davis with the robot arm activity and will operate several experiments. There is some fog in the KSC area, and that is expected to burn away as the sun continues to rise here in Florida, and looking for favorable weather conditions for our launch of Discovery today. All countdown events are going well. We expect the crew to arrive at the launch pad's white room at about 8 a.m. Got a lot of well-wishers standing by, ready to wish the crew well before their journey into space. Crew's getting ready for a 10-day mission. We have views now in the crew cabin, and we have guest commentator Marsha Ivins here to help explain what's going on.
What you see here is the commander, Kirk Brown, getting into the commander seat on the left. Joe Tanner, who is the astronaut support person, the ASP, helping him. It's a little difficult to climb up in the vertical position and to get in the seat, so Joe was holding onto his parachute while Kurt gets into the seat. Now he's going to ask him to, as he holds the parachute, pull himself all the way down into the seat to get a good fit in there so they can get the harnesses on him.
The
the same time the commander is being strapped in, we have MS-3, Steve Robinson, being strapped in by Carlos, who is our awesome suit tech on the middeck. This goes on in parallel so that all the crew can get in a timely fashion. The same as Joe was helping on the flight deck, Carlos holds on to the parachute. Steve's got a strap connected to the locker. You can see him holding on to now like a chinning strap that allows him to position himself correctly on the parachute as he gets in. Now we see the birthday boy getting into his seat, the pilot. He's holding on to two handrails, one in the center of the near the windows and one on his right side. And then as they hold his parachute, he pulls himself down into the seat. Bjarne is now in the PS1 seat. You can see his chinning strap that he's got to get himself positioned in the seat. And Carlos will be connecting his cooling water. Last crew member in, Bob Kirby, in the MS2 seat.
Well, I've got you here. I'll give you step 570 to work for the clock if you want for the perform the fuel cell purge on channel 153. Okay, we'll put that into work as well. Do you need a QC there?
And we heard that poll by NASA Test Director Doug Lyons of the launch team indicating that they are ready to continue on with launch today. Standing by now for Jim Harrington, the launch director, to conduct his poll of the management team.
12, I'll run a poll at this time. Copy. Payload director. Payload the ghost. After that, engineering director. Engineering go. Copy that. Safety and mission assurance. Safety and mission assurance is go, Jim. Copy that. Range weather. Roger, sir. We have low constraints to launch. And ops manager. Ops manager, the MMT is not tracking anything, and looks like we're go for launch. You're cleared to proceed with launch count. Copy that. And Discovery, looks like everything's ready to go. You guys have a great mission, and we'll see you back here at the conclusion of the mission, and NTD, you are clear to launch. Copy that, sir. Thank you. Attention all stations. The countdown clock will pick up at T-minus 9 minutes. And 2 minutes and 20 seconds.
T-minus 5 minutes.
Orbiter ATU start. TLT OTC, perform ATU start. ATU start in work. And CDR reconfigure heaters.
The vent hood is situated at the top of the external tank. That will be retracted away in the next few seconds. And the external tank is being pressurized for flight.
TLT OTC, clear the caution warning memory. Verify no unexpected errors. Caution work, OTC. OTC TLT, warning memory cleared. No unexpected errors. Copy. And flight crew, close and lock your visors, initiate O2 flow. On behalf of the launch team, good luck with your mission. And Ramo, happy birthday. We're about to light your candles. Thanks for that birthday wish. Will be the two best candles I ever had. And Discovery copies visors and sit O2. PLS is good for ET, LHT, pressure station.
Water will be dumped onto the launch platform in a few seconds to help suppress the sound and shock of the thrust produced by the shuttle at launch. T-minus 15 seconds. 13, 12, 11, 10, 9, 8. We have a go for maintenance start. 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery on a mission to study planet Earth.
Roll program, Houston. Roger, ready to roll, Discovery.
Houston is now controlling. The roll maneuver is complete, and Discovery is now in a heads-down, wings-level position. All three main engines now throttling down to 67% of rated thrust as the orbiter passes through the area of maximum aerodynamic pressure on the vehicle in the lower regions of the Earth's atmosphere. Telemetry indicates all three auxiliary power units and fuel cells continuing to perform well.
We continue. We're looking at the engines now as they throttle back, so about 67% on all three of the main engines. And looking for Mach 1 right now, making sure the tapes match on both sides, and they did. And we continued on up. And right about now is when the engines start throttling again, throttling up to 104%, the main engines, that is.
Discovery, go at throttle up.
Copy, go at throttle up.
1 minute, 22 seconds into the flight, Discovery's three liquid-fueled engines are now back at full throttle, 104% of rated thrust. Discovery now traveling at a speed of 1,900 miles per hour.
I just called the tail off of the SRBs, and we should see SEP right about now. And there was the big flash of light, and now we've rode to the next, and now we're just on the main engines, and got about 5.5 more minutes to orbit.
Again, telemetry currently indicating all three main engines, auxiliary power units, and fuel cells continuing to perform well. Discovery now at a speed of 2,800 miles per hour, downrange from the Kennedy Space Center, 27 miles. Discovery now at an altitude of 367, downrange from the Kennedy Space Center, 370 miles.
Discovery, single engine Zaragoza, 104.
Copy, single engine Zaragoza, 104.
Now 8 minutes, 43 seconds into the flight, the booster officer here in Mission Control has confirmed an on-time main engine cutoff.
Discovery Houston, we show a nominal MECO. OMS 1 is not required. You have a go for the ET photo DTO.
Copy, nominal MECO, OMS 1 not required.
Discovery. We're in the low hover position and would like to maneuver to the SPA's release position. We have a go to maneuver to release. Discovery Houston, we're about a minute to the ZOE. We'll be back with you at 7 hours, 9 minutes.
Copy, Alan, 7 hours, 9 minutes. Number 339er, colon 25. Number 440, colon 00. Or number 540, colon 30. These are all the ice cap runs and a good chunk of the way through the Brownie and Bushes stuff. But when I was running config MIP at one point, I got the SCP comm lost error. And now when I try to do cold reboot on the system, I get as far as starting on track, and then I get a bit of hieroglyphics, and that's where I've been ending for the last little while. I'm not able to get back by that point.
We copy and we'll look into it, Bjarne.
Discovery with PDF data when you're ready to copy.
We're ready.
Alan. DP Flex troubleshooting part B. Would you like to get into that?
This is the workstation where we operated the robotic arm, which is a Japanese robotic arm, which will be part of the Japanese arm on the space station. These are the two hand controllers. We have a computer here which also controls the arm, as well as some switches.
Hey, Houston Discovery on the wastewater now.
Go ahead, Rommel.
Yeah, before we exceeded the bid temperature, we got to 6%. You all happy with that, or do you want me to dump that last percent out?
No, you're just fine where you are.
Good copy. Swiss, Hell Bob is dead.
And Houston, you should be getting video now.
We have a good picture.
And Houston Discovery, good handheld laser mark, and it agrees with radar.
Copy. Houston Discovery with Earth Vehicle status check. Discovery Houston, we're 2 minutes from the ZOE. We'll be back with you at 0 hours, 17 minutes.
Copy, Houston. Talk to you at 17 minutes. And before you go, just, you probably see this, but we're about 125 feet, closing at 0.25. Houston Discovery DTO complete. We're backing out now.
Copy. Houston Discovery, we show a good grapple. Great job, Discovery. Congratulations on a very smooth rendezvous and grapple. Okay. And Jan, you can go ahead and put deact in work. Houston, we've uplinked orbit and target state sectors and approx-ops covariance matrix.
Okay, we copy that. MET, 9 days, 1 hour, 5-6 minutes, 40 seconds. Discovery, energy, ground track, and nav are go. Latest touchdown prediction is 2,600 feet at 195.
Copy, energy, ground track, nav a go, and 2,600 at 195.
Long-range cameras capturing Discovery at 103,000 feet altitude, traveling 2,500 miles per hour. And Commander Kurt Brown now flying Discovery as the twin sonic booms announce the arrival of the orbiter in the landing site area. Time to touchdown, 3 minutes, 10 seconds.
Discovery on energy at the 180.
Copy, on at 180.
Discovery's altitude is 2,400 feet, traveling 375 miles per hour. And the landing gear is down and locked. Main gear touchdown. And nose gear touchdown. Discovery's rolling out on runway 33 at the Kennedy Space Center, completing 189 orbits of the Earth while traveling 4.7 million miles. STS-85 is the 23rd mission of Discovery and the 86th in the shuttle program's history.
looking at the doors.